Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students Office at the University of East Anglia. This webcast is part of the Steps into Statistics series and concerns measurements of spread 1, range and interquartile range. This guide explains two of the different types of measurement of the spread of a set of data, the range and the interquartile range. Introduction. Measurements of spread, sometimes called measurements of dispersion or variation, are one of the most fundamental and important concepts in statistics. They are part of the set of descriptive statistics and are crucial when you want to compare datasets. Measurements of spread quantify the amount of scatter in a dataset and, in combination with a measure of central tendency, help to give a picture of your data. See Study Guide, Measurements of Central Tendency. If the spread of values in a dataset is large, then the mean will not be as good a representation of the data as when the spread of the data is small. Take care though, as you must consider the magnitude of the numbers in your dataset when making a decision about if the data scatter is large or small. Measures of spread can also help to distinguish between datasets with identical means or medians. For example, consider the two datasets 5, 25, 50, 75, 95 and 35, 40, 50, 60, 75, both of which have identical means and medians. In order to distinguish between them, you need to use other properties of the set. This property is how spread out the data are. In using and choosing an appropriate measurement of spread, careful consideration should be given to what level of data you are analysing. See Study Guide, Levels of Data. For example, the idea of spread for nominal level data is nonsensical, and as a result you should never quote a measurement of spread as a descriptive statistic for a nominal data set. This guide introduces two simple measures of spread suitable for some ordinal, interval and ratio scales, the range and the interquartile range. The most common measures of spread, the standard deviation and variance, are explained in the Study Guide, Measurements of Spread 2. The range. The range is the simplest measurement of spread and is defined as range equals highest value in a dataset minus lowest value in a dataset. The range is easily calculated and can be useful when used in conjunction with the mean. Example: calculate the range for the datasets A equals 5, 25, 50, 75, 95, B equals 35, 40, 50, 60, 75. The equation above tells you that, to calculate the range of a dataset, you simply subtract the minimum value in the dataset from the maximum value in that dataset. For dataset A, the maximum value is 95 and the minimum value is 5. So, the range of dataset A equals 95 minus 5, which equals 90. For dataset B, the maximum value is 75 and the minimum value is 35. So, range of dataset B equals 75 minus 35, which equals 40. The range is a useful tool to detect any errors in data entry. For example, if the range of ages of pupils in a primary school is 20 years, you know that there is a data entry mistake. However, the range only takes into account two data points, the smallest and the largest, and is easily distorted by extreme values or outliers in the dataset. Therefore, you should exercise caution when using it. The interquartile range. The potential problem of outliers can be overcome by using a more robust measurement of spread, the interquartile range, or IQR. The IQR follows a similar idea to that of the range, but does not use the highest and lowest values in the dataset, but those at a quarter and 3/4 of the way along when the data is ordered from smallest to largest. Therefore, the IQR looks at the central section of your data, either side of the median. The interquartile range is defined as interquartile range, IQR, equals upper quartile, UQ, value, minus lower quartile, LQ, value, where the lower quartile lies a quarter of the way through the data and the upper quartile lies 3/4 of the way through the data. The study guide Measurements of Central Tendency explains how the median splits the data set in half. In a similar manner, the quartiles split the data set into quarters. Example: 10 students take a test and the results are as follows: 18, 14, 7, 13, 12, 13, 12, 19, 10 and 11. Find the range and the interquartile range for this data set. This example was used to find the median in Study Guide Measurements of Central Tendency. The range is the difference between the highest value and the lowest value, so range equals 19 minus 7, which equals 12. To find the interquartile range, as with finding the median, the data must be arranged in order first. 7, 10, 11, 12, 12, 13, 13, 14, 18, 19. The median is the middle of the two values in the centre of the data. Median equals 12.5. The lower quartile, LQ, is a quarter of a way through the data, halfway between the median and the lowest value in the data set. So, LQ equals 11. The upper quartile, UQ, is 3/4 of the way through the data set, halfway between the median and the highest data value, so UQ equals 14. Therefore, IQR equals UQ minus LQ, which equals 14 minus 11, which equals 3. In other words, the interquartile range is 3. Example: 11 families were asked how many children they had. The replies were 2, 4, 2, 5, 0, 0, 1, 3, 1, 1 and 2. Find the range and the interquartile range for this data set. A similar example was used to find a median in the study guide Measurements of Central Tendency. The range is the difference between the highest value and the lowest value, so range equals 5 minus 0, which equals 5. As before, the data must be arranged in order first. 0, 0, 1, 1, 1, 2, 2, 2, 3, 4, 5. The median is the central value, the sixth of the data set. The lower quartile is a quarter of the way through the data. For the above data, the lower quartile is the mean of the third and the fourth data points. As they are both 1, LQ equals 1 plus 1 divided by 2, which equals 1. The upper quartile is 3/4 of the way through the data set. For the data above, this is the mean of the 8th and 9th data points, and so UQ equals 2 plus 3, all divided by 2, which equals 2.5. Therefore, IQR equals UQ minus LQ, which equals 2.5 minus 1, which equals 1.5. The interquartile range is not affected by outliers in the data set, and so, in many cases, is a better measure of spread than the range. However, it has the disadvantage that the first and fourth quarters of the data are not used, so any outliers or data skew within those parts of the data would not be taken into account in this measure of spread. Further guidance and information. If you have any further questions about statistics or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.